Looking at the crystal, blue night sky with the naked eye, you can see which planets. Technically, you can see all of them, at one time or another. Except for Neptune. It is the smallest gas planet and also the farthest away. And it is a place that is hard to understand, unlike what we've known, with a dynamic atmosphere, giant storms, and incredibly fast winds. Why is this planet so fascinating? Neptune is the only planet found through mathematical prediction. You see, when Uranus was discovered and astronomers were charting its orbit, they noticed that Uranus did not follow their models. From the perturbed orbit of Uranus, Leverrier in 1846 concluded that there must be another undiscovered planet, and he did its position. Remarkably, Johann Galilei was able to find it just off the predicted spot. Titan, Neptune's largest moon, was discovered just days later. But since then, we've known very little about Neptune due to its distance from Earth, and its relatively small size compared to neighboring planets, meaning it cannot be easily studied from ground-based telescopes. Not until 1989, when Voyager 2 visited Neptune, did a wealth of information about this planet become revealed. Suddenly, we could see what the planet looked like. Its rings were confirmed, and many previously unknown moons were discovered. But fast forward to today, what do we know about this planet now? Since Pluto was downgraded from planet status, Neptune stepped up as the 8th and farthest planet from the Sun. It orbits at an average distance of about 30 from the Sun, meaning it's over 30 times as far from the Sun as Earth's orbit is from the Sun. In other words, 30 is equivalent to 4.5 billion kilometers. And from that, you can see why a space probe using current technology would take 13 years to reach Neptune. 4.5 billion kilometers is a considerable distance. Because of its distant orbit, it takes a whopping 165 years to orbit the Sun once. That means we have only observed one Neptune year since its discovery. This distance from the Sun results in an average atmospheric temperature of a chilly -201 degrees Celsius. Its axial tilt is 28 degrees, similar to Earth and Mars, which have corresponding tilts of 23 degrees and 25 degrees. This means it also has similar seasons to Earth and Mars. The big difference is that these 4 seasons last about 40 years each. Currently, the Southern Hemisphere is experiencing summer, and during this summer, the Southern Hemisphere has actually become brighter, thought to be the result of interaction with the Sun. This is strange, as you might think, because the Sun on Neptune is over 900 times dimmer than on Earth, so from that distance, it will have much impact. But even if it's just a small influence, it still creates an effect. And the brightness of the hemisphere is thought to be because it warms up about 10 degrees Celsius higher than the rest of the planet. This relatively higher temperature has released frozen methane into the stratosphere, while elsewhere on the planet, it remains frozen and deeper below the troposphere. The lowest layer of a planet's atmosphere is the troposphere, followed by the stratosphere. Above those layers is the mesosphere, the thermosphere, and then the exosphere. If you look at the weather on Neptune, it actually has the fastest wind speeds compared to any other planet, with wind speeds blowing westward along the equator reaching an astonishing 2.160 km/h, nearly a supersonic stream. Interestingly, most of the wind travels opposite the rotation of the planet. Rings are also formed on the planet as well as giant storms. When Voyager 2 passed by the planet in 1989, it saw the Great Dark Spot, a storm the size of Earth crossing its atmosphere. It also saw a smaller storm called the Small Dark Spot in the south of its larger sibling. When Voyager 2 approached Neptune, this storm changed color from dark to light. When the Hubble Space Telescope was launched, astronomers were curious to see the fate of these storms, to learn whether they are a permanent feature like Jupiter's Great Red Spot. But when Hubble looked at Neptune in 1994, they had disappeared. The storms come and go, and since then, the large bright clouds at altitudes have also come and gone. But why does Uranus, with similar composition and size to Neptune, not have such a chaotic atmosphere? Wind speeds on Uranus are so fast, but they can't compete with Neptune's at speeds of 900 km. All of this could only be due to interaction with the Sun and its seasons. There's something different here to explain. We've mentioned that Neptune is the farthest planet from the Sun, so you might think it's also the coldest planet. But actually, Uranus is the coldest planet in our solar system. Neptune radiates heat from within, while Uranus does not emit any excess heat. This could be because a large object the size of Earth might have struck Uranus billions of years ago, depleting all of its original heat. Now, the more active weather on Neptune could partly be due to its higher internal heat. What exactly is Neptune made of? Its internal structure and atmosphere are believed to be very similar to Uranus. The atmosphere of the planet consists mainly of 80% hydrogen and 19% helium, with a small amount of methane gas. It's this methane that gives Neptune its blue hue, though it has a deeper blue compared to the cyan blue of Uranus. Again, like Uranus, here's a slushy mantle of water, ammonia, and methane gases surrounding the core, where the core and mantle meet. Pressures are so high that methane could break down, and diamonds form under those pressures. These may not be the diamonds as we know them, but there could be a liquid carbon ocean with solid diamonds floating in it and diamond hailstones raining down to the core. This is just a theory, though current technology has started to approach recreating such pressures around the core of Neptune. Pressures are thought to be about 700 gigapascals, about 7 million times that of Earth's atmospheric pressure on its surface. Even the magnetic fields of the two giant ice planets have similarities. Neptune's magnetic field is tilted 47 degrees from its axis of rotation. When Voyager 2 discovered this about Uranus, the first theory was that it had something to do with its unusual axial tilt. But then it found the same about Neptune, which has a more normal axial tilt. The current theory is that the magnetic field is not generated in the core, but by the conductive liquid mantle. Though the mantle shifts the magnetic field away from the core, causing this strange offset from the axis of rotation. All planets in the solar system don't really have perfectly aligned magnetic fields. Even Earth's magnetic north is different from the location of the North Pole. But only Uranus and Neptune have such tilted magnetospheres. The auroras also exist on Neptune, but they are unusual compared to what you might expect because they are extremely faint due to the charged particles from the Sun. And due to the orientation of the magnetosphere, they are mostly type B auroras or polar arcs. Earth also has these, but they are invisible, and you need scientific instruments to know they are there. They could stretch across the sky, and you wouldn't really know about it. The difference with the polar arcs is they are not around the poles, but at mid-latitudes. Let's forget Neptune for now, and talk about its ring system. Like all giant gas planets, Neptune has a ring system, although it is very faint because it is not dense and is extremely dark. These rings are against the black backdrop of space and are also far from the Sun, making them hard to see. There are a total of 5 in all rings, and all of them are named after individuals who have been involved in the discovery and study of Neptune. The closest is the faint and quite broad Galilee, about 2.0 kilometers wide. Following is the first bright ring, Voyager, though faint. It's just 113 kilometers wide. Next and connected is the faint colossal ring, of 4.0 kilometers wide. And in the edge of this ring is Argo. It's a bit brighter than less than 1 kilometers wide. Finally, the outermost ring, Atoms, has been studied the most. It's just 35 kilometers wide. It is one of the brightest rings. It's especially interesting because it is slightly inclined and has bright arcs inside it. These arcs have been quite stable since they were first observed in 1980, but typically, planetary rings are uniform throughout. Arcs should be clusters of material that clump together in the ring. But the reason for this is currently unknown. Finally, let's talk about Neptune's moons. Neptune has 14 known moons, named after sea gods in Greek mythology. The most famous and largest to date is the moon Triton, It actually accounts for more than the mass of all other moons combined. Fans claim it is one of the most beautiful moons in our system due to its fantastic patterns and burnt orange color. The most interesting thing about Triton is the fact that it orbits in a retrograde orbit and is also inclined to Neptune's rotation, implying it may have been a captured object rather than something that formed with Neptune. Triton may be the cause of Neptune's rings, as it could disrupt the orbits of potential moons, causing them to collide and break into the debris that forms the rings. Larger than the dwarf planet Pluto, Triton also has a thin atmosphere. Voyager 2 even saw faint clouds as it passed by the large moon. The next largest moon is Farthest, actually larger than 400 kilometers compared to the spherical moon of Saturn, Mimas. Why it isn't spherical is explained by past impacts of objects onto the moon, leaving huge craters. Until moons regularly orbit within the rings, and some guide shepherd moons, helping to maintain the ring structure. The irregular moons likely are captured objects, some of which orbit in prograde and others in retrograde. The outermost moons of Neptune, Nessa and Samoth, are the furthest of any known moons around a planet, taking 25 years to orbit Neptune just once. This is because Neptune has a very large hill sphere. A hill sphere is the region where a planet's gravitational pull is stronger than the Sun's. Neptune's large hill sphere is due to its far distance from the Sun. This solar gravity has less influence around Neptune than around Jupiter, the largest planet in our solar system. To date, Neptune continues to hold a mystique that challenges space researchers. This has continued to challenge scientists in understanding Neptune further and how it contributes to our knowledge of the universe.